So we have studied about what is meant by gradient operation, what is the divergence operation. Next, consider third vector differentiation. So curl operation. Third one, curl operation. So already we have studied that the curl operation is an application of cross product. Okay, so it is a cross product between del vector and any other vector. So here the combination of del cross is named as curl operation. Okay, we know that. So now let us consider what is the formula for this curl operation. So here it is given by, I consider first one is a del vector. Now we need to perform cross product with any vector. So I am going to make an assumption that the vector is a bar. Okay, so this is called as curl of a bar. Now, so here how do we evaluate the cross product between two vectors? So to evaluate this cross product, we write equation in terms of determinant. We write equation in terms of determinant. So in the determinant, first row must be unit vectors. Okay. So unit vectors are represented with a x cap, ay cap, az cap. So first row must be filled with unit vectors. Okay. Now in the second row, just observe this cross product. In the cross product, first vector is del. Okay. So in the second row, we should write what are the components of first vector in the cross product. Okay. So in the del operator, x component is dou by dou x, y component is dou by dou y, and z component is dou by dou z. These are nothing but components of first vector in the cross product. First vector in the cross product. Okay. And next one, third row. Third row must be components of second vector in the cross product. In this cross product, second vector is a bar and its x component is ax, y component is ay, and z component is az. Okay. So this row is nothing but components of second vector in the cross product. Second vector in the cross product. Okay. Now this determinant is the formula for curl of a bar. Okay. Just if you evaluate this determinant, we get the cross product between del and a bar or curl of a bar. Okay. So now just observe this one. So we have applied the curl operation on vector quantity. Okay. So this curl operation is applied on a bar. A bar is a vector quantity. And what is the results? So here if you evaluate this determinant, we get the results. In the results, there will be ax cap, there will be ay cap, and there will be az cap. They represents direction. Okay. So the results of cross product contains unit vectors. So results is a vector. So what you can observe here is, so curl operation is applicable only on vectors and results is also a vector. Okay. So this is about the curl formula. Okay. So finally we can say that this is the formula for curl operation. This is the formula for curl operation. Okay. So once if you know curl operation, then we will say what is the meaning of this curl operation. Okay. So in general, you know what is meant by curl or what is meant by curling. Okay. Curling means rotating or circulating. Okay. Similarly, when you apply this curl operation on any vector, this curl operation finds amount of circulation, or amount of rotation in the given vector field. Okay. So that means when we apply curl operation, we are going to find out amount of rotation or circulation in the given vector field. Okay. So for example, I will give an example and I will explain. Example. Okay. So let us consider there is a vector field as shown in the diagram. is the field. Okay. So, this field can be represented mathematically. Okay. So, I represent this field with the representation A bar. Okay. So, now let us find out curl of A bar here. Curl of A bar. Okay. Now, I would like to know here the curl of A bar value is a 0 or non-zero. Okay. So, now just see here, what does curl operation finds? Curl operation finds amount of circulation or rotation. Okay. So, that means we have applied curl operation on A bar. That means we are finding amount of rotation or circulation in A bar. Okay. For that, just observe this diagram. A bar diagram is shown here. Okay. A bar field is shown here. So, by observing this diagram or field, can you tell me, does A bar is rotating or not? Yes. Okay. So, the vector field A bar has the rotational property, or A bar is rotating. A bar is rotating. Okay. So, then definitely curl of A bar is non-zero. Okay. So, simply we say that A bar is a rotating field. Okay. A bar is a rotating field. A bar is a rotating field. Okay. Similarly, let me tell you one more example. Another example. In this example, let us consider previous example we studied in divergence. There is an electric field due to positive charge. So, always electric field will move away from the positive charge like this. This is the field. Okay. So, this field is denoted with E1 bar, E1 bar, or we say E1 bar is electric field due to positive charge. Okay. So, let us find what is the curl of E1 bar. What is curl of E1 bar? Okay. So, now just observe here, we are finding curl of E1 bar means we are finding amount of rotation or amount of circulation in the vector field E1 bar. Okay. So, you just observe this diagram, is this field is rotating or not? Okay. Here everywhere the field is represented with the straight lines. Okay. So, straight line never rotates. So, all the field lines or flux lines are represented with straight lines. Straight line rotation is 0 or straight line never rotates. Okay. So, amount of rotation in E bar must be equal to 0. Okay. So, if curl of any vector field is 0, then the vector field is called as a irrotational field. E1 bar is called irrotational field, or this is called curl free field. Curl free field, or it is called conservative field. Conservative field, or it is called non-vertex field. Non-vertex field. Okay. So, this is when curl of any vector field is 0, we generally most frequently we say that conservative field or curl free field or irrotational field. Okay. So, this is an example of curl operation. Okay. So, here we have seen this example for curl of A bar. So, this is a rotational field, the field which is rotating. Okay. So, now if we consider, we have calculated curl of A bar which is non-zero, and that is why it is called as A bar is called as a rotating field. Okay. So, consider here del cross A bar. Here del is a vector, A bar is a vector. The cross product between two vectors is also again vector. This entire quantity is again vector. We know that vector should have magnitude and also direction. So, vector should have magnitude and should have direction. should have direction. Okay. So what is the magnitude of curl of A bar? So as I said, curl operation finds amount of rotation or amount of circulation. Okay. So magnitude, we say that magnitude represents amount of rotation or circulation That's fine. So then what is the direction? What is the direction of curl of A bar? Okay. So in this diagram, what you can observe here is A bar is rotating. Okay. So A bar is rotating like this. So this is the direction of A bar. If A bar direction is this clockwise as shown here. Okay. A bar direction is clockwise shown in the diagram. Then what should be the direction of curl of A bar? Okay. So how do we find the direction of curl of any vector? That's what we require. Okay. So if you want to find the curl direction, you just observe what involves in the curl operation. There is a cross product. Okay. If you know how to find the direction of cross product, then you can find out the direction of curl operation. Okay. So already you might have studied in school days that how do we find the cross product direction between any two vectors. Okay. So whenever we have two vectors, A bar and B bar, there are two vectors. Okay. If you perform cross product between A bar and B bar, that is A bar cross B bar, how do we find its direction? Okay. Here the rule of cross product is, so here the cross product between any two vectors must be perpendicular to its first vector and perpendicular to its second vector. Okay. So A bar cross B bar direction should be perpendicular to its first vector A bar, perpendicular to its second vector B bar. Okay. So I consider this one. This is the direction of A bar cross B bar. So which is perpendicular to vector A bar and also perpendicular to vector B bar. Okay. And also it satisfies right hand thumb rule. Okay. Or right hand screw rule. The cross product direction is always given by right hand thumb rule. I'll write here. Direction is given by right hand thumb rule or right hand screw rule. Right hand screw rule. Okay. You can apply anything here. Just observe this one. So if you observe here, we are finding A bar cross B bar. So draw a curve from A bar to B bar. Okay. Now let us apply right hand thumb rule. So this is the right hand thumb rule. Okay. These four fingers indicates rotation from A bar to B bar. Then thumb finger shows upward direction. There is the direction of A bar cross B bar. Okay. So just apply right hand thumb rule here to find the A bar cross B bar direction. Okay. As shown in the diagram. Or we can do another way. We apply right hand screw rule. We just consider a screw here. Just assume a screw here. This is called as right handed screw. Okay. So if you have two vectors A bar and B bar, and if you want to perform A bar cross B bar, okay, then you just rotate screw from A bar to B bar. Okay. When you rotate the screw from A bar to B bar, just we are performing A bar cross B bar, you just how this screw is going to move. When you are rotating from A to B, this is right handed screw, screw will be loosened. Okay. So then it is going to move in upward direction. There is a direction of A bar cross B bar. Okay. So either you apply right hand thumb rule or you apply right hand screw rule to find the cross product between any two unit vectors. Okay. Similarly, with the help of this cross product or with the help of right hand thumb rule, we can find out the direction of curl operation. Okay. So here we have curl of A bar. Okay. So just see here. So this is the diagram. So where this take this right hand thumb and place like this. Okay. This four fingers rotation should be towards the second vector. What is the second vector here? A bar. Okay. So always we should have this rotation or curve must be from first vector to second vector or towards the second vector. Okay. So these 4 fingers indicates rotation along the second vector or towards the second vector. Okay. Then thumb finger shows it's a curl operation direction. Okay. So according to right hand thumb rule, this curl operation direction is into the board. Okay. So the direction of curl operation is into the board. That is denoted with a circle with cross. Okay. So this indicates direction of curl operation. Direction of del cross A bar or curl of A bar. Curl of A bar. Okay. So and also you have to you should know the directions what is the representation for into the board and outwards the board. Okay. So just we will see what is the direction into the board, outwards the board. So here consider symbols. Circle with a cross is called into the paper or into the board. Okay. Or inwards. And another symbol, circle with a dot, is called as outwards. Okay. So here, which is going into the board or into the paper. Here, any quantity that is coming outwards the board or outwards the paper. Okay. So simply you remember that into is into. Okay. Another symbol is outwards. So these are the symbols we use to represent the direction of any physical quantity or flux or field.